First, let's take a look at this question. A high-altitude balloon is filled with 1.36 times 10 to the 4th liters of hydrogen at a temperature of 24 degrees Celsius and a pressure of 742 torr. So far, we have three quantities before the change of conditions. So let's just label them. This is obviously is a volume. We can call that V1. Then temperature, T1. Pressure, P1. So that's before the condition changes. That's why I use the subscript 1. Once you see the units for temperature of degrees Celsius in your mind, immediately you should think about changing this unit of Celsius to Kelvin scale. Pressure, torr, so I need to change that to atmospheric pressure. What is the volume in liters of the balloon at the height of 20 kilometers, where the temperature is negative 48 degrees Celsius? So that should be T2. And the pressure is 63.1 torr. That's P2. You may ask, okay, what should I label? These are 20 kilometers of height. No, actually, that quantity is not needed in this calculation. It's just kind of a statement for this question, because if you go to a higher altitude, use your common sense or common knowledge, the temperature should be much lower. I mean, that's 20 kilometers up in the sky, so very low temperature, and then the pressure is also very low, okay? So therefore, what is the volume? That's really what we need to find out, V2. Since there are three variables before the change, volume, temperature, and pressure, so then we'll need all three parameters. Then we can actually write down this combined gas law equation. And from this, we should be able to write down V2 equals P1 V1 over T1 times move P2 and T2 to the other side, then flip, all right? Flip them. That should be T2, P2. Now, let's start the calculation. So P1 is 742 torr, and we need to convert that from torr to atmosphere. 1 atmosphere equals 760 torr. Now V1 equals 1.36 times 10 to the 4th liters. And then T2, negative 48, that's degrees Celsius. We need to change that to Kelvin by adding 273.15. On the bottom, T1, which is 24 degrees Celsius. Again, we need to convert that to Kelvin. Then P2 is a 63.1 torr, and we need to convert that to atmosphere. Converting from put on bottom and converting to put it on top so that, the units can be canceled. All right, same thing with here. Okay, and now let's take a look at atmosphere. We have one atmosphere here, another one here, and then Kelvin, here, one there. Okay, the only unit left is the liters. All right, so therefore, for the final answer, that should carry a unit of liter. Therefore, the final answer is 1.21 times 10 to the 5th liters.